So we'd like to thank you today for listening to our presentation. You know, because of the snowy weather and the upcoming snowstorms we're going to be having, we would like to propose a solution to the troubles that a lot of people have in shoveling their driveway. And we wanted to come up with a new way to kind of heat a driveway. And we wanted to answer the question of, will putting a controller on a heated driveway ultimately reduce costs for homeowners and business owners?
So with that, we started by doing an energy balance on the driveway to model the temperature changing over time. And we included in that balance the heat coming in from the heater and then the heat loss due to the conduction through the ground, convection with the air, heat of fusion from the snow melting, and heat of vaporization from the melting snow vaporizing. And we did that with assuming that there is wind at a constant velocity of 5 miles per hour. And then once with that equation, we linearized it with respect to the variables, the voltage, the temperature of the driveway, the temperature of the air, and the temperature of the ground, the height of the snow, and the partial pressure of the air. And with the linearized equation, we then came up with alphas based on tabulated values. We looked up constants online and things like that and used heat and mass correlations to get our H's and calculated alphas, which would be used in our transfer functions later.
Okay, as you see here, this is our Simulink program, and right here is our process. We have a PID controller here, and here we have a nonlinear transfer function. We had to use a MATLAB function where the the voltage was times by itself, times by the change of voltage, times by 2, which that gave us about the gain. And then this gave us the dynamics of the process. And up here are all the different disturbances. Here we have the snowfall, we have our humidity here, and then here we have the air temperature. And so as shown in these graphs, so the snowfall is random, with it going between about 0 to 2 inches, and it changes every 2 hours. Most of the time it's not snowing, so most of the time it's 0. And then the air temperature is a sinusoidal. Here we have day and here we have night as the temperature increases and decreases due to the setting and rising of the sun. And then the humidity follows the snowfall. When it starts to snow, the humidity starts to rise, and so we have it peaking and rising with the snowfall.
So our last figure is right there. It's the figure of temperature of the concrete versus time. And you can't really see on the graph very well the numbers, but our temperature varied by 0.03, our graph right there. And that shows us that our PID controller was really accurate and really good. And so because of that, what we calculated over a 5-day period of time how many kilowatts we used, and it was approximately 92. And without the use of a controller, we also calculated that the cost for heating a driveway would be about $15.30. But when we used the controller, our cost would be $8. So it essentially cut our costs in half for heating a driveway. So our results were good, and they were, we were able to reduce the cost by half, which is awesome. And therefore, we would recommend as a group that those who want to have a heated driveway, use a controller to be cost effective and efficient in the long run.